Hi, everyone. I'm Caitlin Burns, and I'd love to welcome you tonight to Autorama. And tonight we have a great panel discussion planned, The Future of Rapid Prototyping. We've got a great group today, and to start off real quick, I'm your moderator, Caitlin Burns. I'm a business consultant for media companies, and I'm COO of Datavized, a immersive design studio that focuses on data visualization in virtual reality and augmented reality. I'm filling in tonight for our panel host, Eric Tinker of the Spry Group. And I'd like to introduce the rest of our panel right now. Why don't we just go down here? We've got two of our panelists in the studio tonight, and one of them coming in through the magic of the internet. So why don't we start here in the studio with you, Andrew. Just a little bit about yourself.
Okay, so my name is Andrew Politi. I work for Bot Factory, and we're basically a company that makes a desktop circuit printer. What our machine does is it will take an electronic design that you have, it will print it out, and it will also assemble it too. So we're basically helping rapid prototyping from the electronics point of view.
DUANN, just a brief bit about yourself.
That's cool. My name is DUANN SCOTT. I'm with Autodesk, working on the Spark platform, which is a platform to help realize 3D printing to make it work, because there's so many bad experiences.
And coming to us from far, far away tonight is Scott Biben. Scott, why don't you introduce yourself a little?
Hello there, everyone. Hi. So my name is Scott Biben. I'm one of the core members of SorcerBot, which is a version of the RepRap, which is a self-replicating 3D printer project. I'm also one of the co-designers of the Mandelbot, which is another version of the RepRap, and the function is the key. And I guess that's what I'm doing in terms of 3D printing currently. And I use my 3D printers that I design in a show. So it's a show called Groucho Fractal, which is a bike-powered show where audience members use brain-computer interface in order to make 3D printed organic vegan snacks.
All of that stuff is brought to us by the future in which we live. 20 years ago, we would never have imagined a live show in which we prototype and print vegan snacks. Or we might have, but there would have been a lot more cooking involved. So
Yes.
we look at things that are going on in all sorts of different industries and all sorts of different activities. And our ability to conceive and bring to life ideas has changed insanely in the past 10 years. What are some of the big moments in developing your ideas and developing your projects that brought you to where you are now? What's something like that blew your mind and let you understand the potential of what you're doing today?
So one of the things that really blew my mind was just seeing what people can do with electronics and how electronics are really in every aspect of our lives. There are very few devices now that don't have electronics embedded in them. So just being able to think that we can make electronics smaller, we can make them faster, we can help people build a device that isn't just a object, but it's actually something with brains and can sense things and can react to them. That's one thing that I thought was really amazing and really helped me go forward with my project and making sure that electronics can be made quickly and easily by just about anyone.
Yeah, for me it was looking at, I was working as an industrial designer, and every time I stopped working on a project, I stopped getting paid. I think that's lame. I was looking at software developers doing apps for the iPhone, and they could make a project once and sell it multiple times and get this passive income. And so what I was thinking was, why can't a product designer do that same thing? And that's where 3D printing online with a service bureau can help that happen, because you can design something once and sell it to consumers multiple times. And I think that has potential to extend, especially once you include electronics. So if you had a service bureau doing electronics as well as 3D printing, then you could conceivably bring a product to market with zero risk, just your time, which is the way things could be, and we can be super agile and move way faster than big corporations can with bringing a product to market.
That's very interesting. Scott, what is a moment in your history that brought this whole idea to life for you?
Well, I come from the world of do-it-yourself, radical media, and the punk rock scene, where we would create our own media, be it recordings of bands or zines. So when I started becoming interested in 3D printing through the RepRap project, I was completely fascinated by, I guess, a further extension of people's ability to be able to express themselves. The 3D printing is not actually new. It's been around for a while, but it was only accessible to people who had access to industrial machines, like machines that would cost hundreds of thousands, if not millions of dollars. So, unless you were lucky enough to have access to one of those, you wouldn't be able to play around and prototype some of your ideas. So, as a hobbyist 3D printer came about, I was really fascinated with this whole idea of being able to, make my ideas. And so I actually got into designing 3D printers rather than just 3D printing itself, because I wanted to further explore, the creation of tools for people to be able to express themselves. So, yeah, the big moment was the discovery of the RepRap, and the biggest moment was probably the discovery of the Fab at Home 3D printer in about 2009 or 2010, which was the first 3D food printer. It came out of Cornell University, and that was one of the big inspirations for the show.
That's really fascinating stuff. And one of the things we hear over and over again when we're talking about rapid prototyping and 3D printing, and I'd love for you to take a crack at this one, Andrew. What is it about these tools that why are we seeing so many tools now that are helping put this power into people's hands? And what's your experience building one that really brings that to life? Yeah.
I think we're seeing a lot of these tools now because there's an open aspect to them where, like RepRap, that's an open source 3D printer, so a lot of people can, get the design files for it and they can try to make it themselves. So there's kind of this growing movement of people who want to tinker and who want to kind of play with these things, and they now have the resources to try it and experiment with it and improve it and contribute that back to the community. So I think there's a lot of curiosity that we're seeing in people, and an openness where they want to make something and share it with everyone, and instead of wanting to earn money from it or profit in that way, they want to just kind of help their fellow human and have a good time while doing it.
And as a follow-up, why when you were tell us a little bit more about Bot Factory. Why did you choose to pursue this line of development, and what does it mean for the user? Like, what does this give them?
So I kind of chose to work with Bot Factory because it's a really interesting and challenging project. I kind of felt that there was, it's not, when I went to school to become an electrical engineer, it wasn't really easy to make stuff. And once you design something, you have to send it away to be manufactured by someone. So I just love helping people make things. So I also love making electronics. So I figured, why not combine the two and make a device that will help other people make electronics, and kind of, if they have this dream of this great idea, just get rid of the friction that would prevent them from making it, and kind of remove any barriers that people have between, the next great thing that they're going to make and actually getting it made.
to go sort of broader view, there's been a lot of talk about the ways that 3D printing and rapid prototyping are changing the aerospace industry, or changing the way we think about really big engineering projects. My own experience comes from the entertainment industry, where you look at, say, Iron Man 1, where a group of prop designers had to build that entire suit from scratch, and it would take about 2 weeks to get to one prototype, and it would weigh about 150 pounds. The same sort of idea, building a suit for Iron Man 2, when they moved to 3D printing, it meant within 24 hours, they could have a suit design that they could put onto a body that's about 30 pounds. Those are huge differences in weight and spending and the ability to unlock creativity. DUANN, why don't you tell us a little bit about some of the challenges that you find working with big groups and big workflows, and what are some of the solutions you've really been excited about seeing to market?
Yeah. So the aerospace industry is super excited about 3D printing because they can lightweight parts to make them equal strength, but way lighter. So the cost of putting it up in the air is reduced massively, and the overall lifetime savings is huge. Unfortunately, to get something in the air has to go through regulatory testing, and the idea of 3D printing is you make each part specifically for the use case. And so if you're making each part separately again and again and again, then the regulatory framework isn't there in place for it. So it's a huge challenge. And that's why we only see parts that aren't mission critical in flight now, because they can't make a bracket which takes all the stress and run that through. So that's we need to reapproach the way we look at approval systems. So same with medical, dental, and aerospace.
And I would guess intellectual property as well. What does it mean to be taking something that is digital and turning it into a physical object with that much ability to iterate?
Yeah, there's a lot of people thinking that DRM is really important in 3D printing. I'm not sure that it is, because people don't transfer files to people they don't trust. And the internet has a pretty good secure system. We do our banking, we do all of our communication, we do everything online. So these are problems that have been solved. The issue is repeatability based on the setup of the machine. So if you print a titanium part and it's in one orientation in a certain part of the build platform of a machine, and it works fine, if you print it again in a different orientation, then it will fail, perhaps. And so what's more important is to ensure that the machine settings are locked in place more than the IP.
And then to take it into a totally different category, Scott, you work with food a lot. And there's a lot of talk around food and 3D printing and using these very complex engineering tools to work with organic substrates. There's, of course, the famous X Prize to print a pizza in space. Whoever does that first has a nice grant that's going to be coming in. Tell us a little bit about what it means to print something that's going to be edible. What is the challenge of that? And please go tell us more about that.
Well, the first time I was interested in printing food, the first thing I thought of was like, well, it probably would need to be some type of paste that was pre-processed, and it would probably need to come out of some type of syringe. So when I thought about this, I was thinking like, okay, if we're going to design a syringe, it needs to be really big. So where am I going to find a really big syringe? So the first place I thought about was a veterinary supply place. So I looked for a syringe used for inseminating cattle. So so a big 60 cc syringe. That was the first thing, in order to have like a big enough chamber to have a whole bunch of goo inside of it. And I went through a whole bunch of different thoughts about like how to actually do it. And in the medical industry, linear actuators are used as a way of depressing syringes in order to deliver medicine. So, when we were designing this, we went through belt-driven systems, and eventually went through. We settled on doing it using a pitch screw as a way of depressing the syringe. The considerations are basically like thinking about, how consistent the goo was that was being extruded from the goo extruder. We actually call it a goo extruder, like GOO. It's just a matter of thinking about the thickness of it, and that actually gave us a whole bunch of other problems, like how strong should the stepper motor be when I don't know, should we use a geared stepper motor? How precise can we be? How much material is going to come out? And because when the goo would come out, it would expand when it hit the air. So should we refrigerate it? Should we heat it? Just a whole bunch of engineering problems came up while doing this. Some other 3D printers that work with food, they use a pressure system that comes from a little pressure pump, and that's pretty brilliant. There's a pancake bot. It's a pancake 3D printer. It's actually a 2D printer technically, but it basically extrudes pancake batter onto a heated surface and makes all different types of shapes. But the part that I find especially interesting in terms of extruding biological materials is how it can be used in medicine. Because it's not just food. It's like like how can you extrude in order to place a bunch of samples onto a plate, like at a certain thickness. Like, can you prepare slides in this way? Also, in terms of extruding sugar, a lot of the way that organs are being grown right now and tissue are being grown right now is on a glucose scaffold. So basically, they'll print scaffold with sugar, like a shape, and the tissue will grow around it. Like the sugar will act as food. So I guess when we're talking about the biological materials or like food, it's like how are we even defining food? And to leave it with another plot twist. One of the things that I'm very interested in, and I have been interested in for a while, is bioremediation, or using mushrooms as a way of eating plastics that are contaminating our environment. And so technically, I guess if you're printing plastics, if you're printing ABS, perhaps you're printing food for the mushrooms. So I don't know, maybe it's all printing of food, depending on who the consumer is of the food.
Yeah. So this gives us an interesting question, talking about things like bioremediation. One of the benefits that 3D printing or rapid prototyping gives us is, in theory, it's creating less waste than if you were building with a big amount of material and you had to chop it down, or you're using a system where it's more precise, so you don't have as much, additional flotsam and jetsam. But let's talk a little bit about the filaments and some of the stuff that you guys use in the work and in what you're thinking about, and how sustainability plays into the ideas and the practice of what you're building.
So I can start with that one. The electronics industry is not really known for being environmentally friendly. So originally when you would go to make a PCB, you would kind of have this big vat of acid, and then you would put some waxy stuff on top of a plastic board that had copper on top of it, and then you would basically eat away all of the copper that you didn't want, and then you would have this kind of big vat of stuff that you needed to get rid of. Well, with additive manufacturing, you don't really need to do that anymore. What my company is doing is we're actually using silver and we're depositing that onto paper right now. So silver is not as bad as, this big like pool of acid that you have to get rid of. So paper is also biodegradable, so you have less to worry about with that. And you don't have to go through more product than what you need to use. You basically take what you need and you only use that. So there's a lot of advances that are possible. And also there's a lot of other companies which, if you look at where electronics prototyping is headed, you could see that they're starting to print organic electronic devices like organic transistors on, non-traditional substrates. So what's interesting about those, this is not something that Bot Factory or my company does, but these are more research projects that big schools and large organizations do. And these organic electronics, they can be biodegradable. So instead of having a landfill with all of these plastic and metallic parts that are never going to break down, you could have, a flexible television screen that when you're done with it, it goes into a landfill, and a short while later or a long while later, it will break down. So it's more environmentally friendly, and there are a lot of benefits to that.
DUANN, you've worked a lot with a variety of different types.
Do you want me to jump in? Sorry.
Give me a second, and then we'll go right back to you, Scott. DUANN, you've worked with a lot of different groups working in these spaces. What sort of what's the filaments with 3D printers? Where is the space with different sorts of materials that are going into these prototypes, and what's some of the impact of that? In addition to precision and efficiency, what are we actually looking at when we're looking at these prototypes?
Yeah, what's interesting is the reason why all the rep started happening is because the patent expired for the technology 4 or 5 years ago. Prior to that, it was completely locked down by one company who had the patent for it, and they did material development at their own pace, which was chillingly slow. It was dire. So once we saw the patent expire, then all of a sudden there's this huge Cambrian explosion of material options, prior to which there was 3 or something. And now there's probably, I don't know, Scott, you probably tell me how many filaments there are available, like 100 different material options. And so as we see the different patents expire in the 3D printing process, so 3D printing is not one machine. It's probably 6 basic technologies which we put under the umbrella of 3D printing, but they're very, very different. There's lasers involved in some, there's powder bed adhesion in some, there's filament extrusion in some. And so each one of these patents is expiring, and as they expire, we see competitors come into the market, taking over the monopoly, and then the competitors open up the platform for more material development. And so we're seeing slowly, as each patent expires, this material development expanding. And so we can go from 1 or 2 plastic options to ceramics, metal, titanium, alloys, gold, silver, bronze, everything, because it's not locked down. And this is where we see the growth happening and the massive change. And this is why you see it in the news, on the internet, because people can get hold of these machines, hack at them, and put weird shit inside of them. And that's what's working.
So essentially, people are rapidly prototyping the machines that help them rapidly prototype.
Yeah, because they can hack them and get access to them. So the old manufacturers of those machines who had the patents for 25 years would not let you play with their machine. They'd say, you use our powder or you lose your warranty. And that's, between 60,000 to 1.4 million, so people didn't play with them. And now, because the patent's expiring, we'll see more experimentation in these materials.
Phenomenal. And Scott, I know you're really eager to weigh in on this sustainability question, and I will let you do that now. Yeah.
Okay. Well, one of the really common materials that's used for printing is PLA, which is polylactic acid, which is often derived from corn and potatoes. It's actually really easy to make this polymer. You use the starch plus oil, and you heat it, you can make a filament that can easily be printed with. What I do to make parts for my printers is I take PLA cups, like from there's a vegan pizzeria in Philadelphia where I'll go and fish cups out of the trash and clean them and shred them in a blender and make a powder. Then I'll mix it with some virgin PLA and put it into a filament extruder, and I'll make my own filament. But I guess I could even do that out of the raw materials. The advantage of PLA is that it is really strong, but it's also biodegradable in landfills. So it's not exactly going to degrade on you in your hand, but because it will dissolve, it will break apart in the presence of methane. It's perfect because you can just compost it, just like throw it in the trash and then or throw it in a compost pile, and it will disappear. I mean, the other thing about 3D printing that I wanted to add is that because you're taking a lot of the kind of surplus aspect out of the manufacturing chain, the distribution chain, and you're only producing really what you need. That's fantastic, because you can actually produce things locally, like versus like having some a little like doodad printed halfway across the world, or maybe via some other method like injection molding, that winds up going to some other part of the world, which goes to some other part of the world, and it winds up traveling all over the world. And the real cost for this doodad that might only cost $1, the real cost is to the biosphere. So often the price of things that we pay does not actually reflect the actual cost. And we always have to remember as engineers that we have to figure in the cost of cleaning up our mess, even if we're not paying. I don't know. I always like to think about the cleanup cost as part of the bigger picture, rather than just the cost of bringing it to the consumer and then letting them have the responsibility of figuring it out.
Now, you bring up a really good point, talking about being able to create things locally. And one of the things we're seeing from rapid prototyping, and I think we've brought up in different ways, is we suddenly have the opportunity to put rapid prototyping into the hands of so many more people, because it's low to the ground, because you can suddenly make things without the gigantic investment in a huge amount of physical manufacturing machines, the way one had to before. What has changed about this marketplace, and how does that ability to customize, what does that mean to the products that you're building?
So I think it means a couple of things. One, it means you could kind of keep all of your designs in-house. So you don't have to worry about sending your designs out to someone else and having them build it and possibly stealing your idea. So you build it, prototype it all within, your offices. And you don't worry a year later that someone else is coming out with a knockoff because they happened to get your design files from your manufacturer. Another thing is you can see more of a distributed sort of manufacturing, where maybe you don't have all of, like, instead of going to one manufacturer for everything, you could kind of outsource your work to a couple of different local manufacturers. So you could kind of scale when you need it, instead of having to, go through injection molding with, a order for 10,000 or more parts. You could just kind of make what you need when you need it. And with that, you can basically always have your newest customers on the newest version of your product. So if you start designing something in January, you get out, a couple of products a week, and you find that there's a much better way to do it. You can incorporate that change into the orders that people place that you're shipping in February. So you kind of have more of a rolling product update that you didn't really have with more traditional manufacturing methods. So those are some of the changes that you get to see with this technology.
Yeah, it's digital manufacturing, so the same rules that happen for software happen for products now. So you can iterate and keep on improving. Unfortunately, you can't give someone an update and change their product afterwards until we have some sort of quantum entanglement.
Yeah.
But it means at least you can continue to iterate. And one thing you said about someone can't steal your idea because they don't have your files. They can steal your idea way faster because they have the same access to the tools that you do. So if you're using a certain technology and it's accessible everywhere, then so does your competitor, and they can take your idea and improve upon it and then go to market. So I think it makes people more agile and iterate much faster, but there's also people knocking at your door all the time or biting at your heels. So it means you have to be good, otherwise someone's going to take over.
Now, the speed of business being much, much faster is really compelling. But on the other side of that, what does it mean for the opportunity of business? Being able to have a much more diverse set of products or opportunities in that consumer product space. Yeah. DUANN, I know you've done some work on this. Maybe you'd like to share an anecdote.
I guess I look at like it's Detroit versus New York. Yeah, Detroit made cars, and New York made lots of different things. And when cars didn't work out so well, Detroit is screwed, whereas New York keeps on evolving because it's got this diversity. I guess it can work negatively as well. So if you look at what Quirky did, in that they were trying to put out like 2 products a week or something, and they just tanked because they couldn't focus and they couldn't iterate on their designs. They would punch something out and then just run to the next thing. So I think we need some sort of balance between this diversity and also focusing on what you do best. Because if you made a printer which printed food and electronics and and human cells, I'm pretty sure that 2 of them may not work out well.
And Scott, your work provides a really interesting case study because you're dealing not just with rapid prototyping and printing pieces, but a live show. How does that work for you with a live audience, building something and having a result while you're there? What are some of the challenges you face with something that's moving that quickly when you have to perform?
Well, one of my favorite lines from the movie Spaceballs is, "Even in the future, nothing works." So I guess when things don't work, I always have to have a good sense of humor. But having things like having so many different variables operating at the same time really pushes me to kind of getting things together as well as possible. There have been so many different instances where I've been, like in the middle of the show, and then the 3D printer doesn't work, or like the brain-computer interface device doesn't work, or someone is intoxicated and they trip over the micro power grid, and I'm worried they're going to get electrocuted. I mean, all these different parts are going on at the same time, and wow, the challenges. I mean, I guess the challenge is really in keeping the flow going and never really letting technical glitches get in the way of the flow of the show. So basically, just have to laugh when things go wrong, and and just kind of you laugh at yourself, you laugh along with other people, and you just shrug your shoulders. They're like, "Oh, okay, sure, it doesn't work. Okay, here, look at this. I can do this." I don't know. I guess distraction tactics are really important.
Speaking of distraction tactics, we've talked a lot about the physical manufacturing side of rapid prototyping. what goes into the digital side, the conceptual side, where you're designing these pieces now that's new? What have been some of the challenges of connecting them to these physical manufacturers? And what can we do now that we couldn't 5 years ago or 10 years ago?
In terms of electronics, you can do some interesting things with like flexible circuits that you couldn't do before. You could also print some interesting like capacitive sensors that you couldn't print before, and with some new filaments, you can integrate them into like 3D models and have like this kind of object which it's whatever shape you want, and it can be almost any sort of sensor you want that you really couldn't do before, because you've got more substrates to use, more materials to use, so you have a whole lot more options. And the issue is now having software which can kind of capture all of that complexity without overburdening the designer with, how do I specify what I want made.
Yeah, so we need a new generation of software for these manufacturing tools. So currently everyone's using engineering software that was designed for subtractive manufacturing, so for milling, machining, folding, bending, injection molding. But you need to approach design in such a different way when it's additive, because you lay down particles where you need them and you don't where you don't want them. You just let it be. And the design tools don't really exist for that yet. And so we're working with one company called Voxel 8, who are based out of Boston, who are making electronics 3D printer with componentry. So you can print a microphone, it can lay the traces in 3D, you can put the components in, and you can print this solid object which has all the embedded parts. But there were no design tools to do that. So they had a machine, but no way to get the idea to the machine. So we developed some software in coordination with them so that they can actually use their machine. And we're going to need to see more of that. So when it comes to multi-material 3D printing, there's no actual software which tells you how to do multi-material 3D printing, yet there's a multi-material 3D printer. So we need new software to sort of unlock the potential that all these machines now have.
And Scott, how do you go about, is there a digital development side to the work you're doing, or is it all still physical? Scott?
There's definitely a digital development. Yes, can you hear me okay?
Yes,
Hello?
yes, we've got you now.
You mean, okay. Yeah, there's a software development side, there's a hardware development side. And both of them are integrated. I mean, you basically you have a problem with the hardware, and you have to kind of figure out how to code it to do the right thing, and then I don't know. It's basically having everything in front of you. Having everything in front of you such that you can very quickly fix things, and you can like make new parts, and that's incredibly helpful for the whole process. I don't know. I actually didn't hear part of the initial question. There was an audio dropout, so I'm not sure if I'm actually answering the question.
No worries. What are some of the challenges to the digital side of the development before you get to the physical manufacture that you found in your process? So what tools do you use? What's been difficult in getting your idea into the computer, then into the development?
Okay.
Yeah.
Okay, so initially we were using a program called OpenSCAD, like a really early version of OpenSCAD. So it was a really slow process of making all the parts, because you had to actually type in all the coordinates for everything that you wanted. Whereas if you're using any other 3D modeling program, it's a little bit easier. You can kind of manipulate it using a mouse. So having to program in every single little bit, it made it I don't know, it made it kind of problematic in terms of getting all the pieces watertight initially. And then we started to use Blender. Blender at a certain point was not really designed for 3D solid objects. It was more so designed for video game development. So the pieces weren't really coming out watertight using that method. So we started to develop another, and kind of using proprietary tools. But our initial goal was to actually use a lot of the open source stuff that was out there. And I guess sometimes when you're actually designing stuff in a three-dimensional environment in this in the kind of in the space of the computer, it's not quite like the materials don't behave in the exact same way. Like like the interior of a nut with which a screw goes through in a digital environment will very easily go through, but the tolerances are only as good as the way that the bolt or the screw might have been milled. So you always need to kind of like think about. You need to think about. No chicken. Sorry, my dog's barking.
Yeah, no,
Sorry.
Yeah, it's definitely something that we hear a lot when we're talking about the digital design and development of these prototypes. What it takes to fill in the little gaps in the digital design to make it work in the manufacture. To switch gears entirely again, and then we're going to open it up to the audience and the live stream for questions. When we're talking about all of these things, we're talking about play and we're talking about experimentation, and we're generally talking about adults. But a lot of the emphasis that's going on in engineering, science, and education is right now focused at kids. Kids who are getting to play with things like little bits kits that are teaching them about the basics of electrical engineering with, plug and play amplifier kits so they can play with the analog as well as think about the digital, and who are spending a significant amount of their free time in Minecraft, where their play is getting them experience with the ideas of three-dimensional design in a three-dimensional environment. What are some of the exciting tools and the mindsets that you think that new generation is going to bring into how we talk about rapid prototype and this typing and this kind of experimentation?
It'll just become the new normal. So a kid who's been exposed to Minecraft, which is probably the most used. So a voxel is a three-dimensional pixel, and Minecraft is easily the most used voxel 3D modeling tool in the world. There's cajillion users. So they understand additive manufacturing in that they understand how to assemble particles to make an object. And they're doing multi-material voxel editing, which is amazing. So for that kid to then go into the next generation of tools, which is a voxel modeler for additive manufacturing, is going to be like, oh yeah, of course. What else would you do? Would you machine it? So I think that the next generation, it'll be natural and the logical way to make things.
Yeah, so I think kind of adding on to that, there's a lot of great tools now for kids to just kind of play around with 3D modeling and things like that. There's like Little Bits is a great way to get introduced to electronics. And then the next step up from that is there's a piece of open source software called Fritzing, where you could kind of design your electronics as if they're right in front of you. It's got a breadboard model, and you just take components, plug them in, and then it makes your schematic for you, which you can then go back and edit, and then it'll take you right on to PCB editing. So there's more tools coming out which are not just for experts, but they kind of walk you through from an introductory beginner lesson to all of the kind of intermediate steps that you would need to go through to become an expert in making these different things.
Great. So let's open up to the audience. We've got a microphone here at the front. If you'd like to ask a question, feel free to come on up. If no one wants to ask a question, I'll keep asking questions. Anyone? Come on up. Come on up to the microphone so the live stream can hear you, please. Yeah.
Do you have a sample?
Oh,
of
do you have a
3D
sample?
thing made?
Oh, did anyone bring anything with you, or?
I have a
No.
keychain, which is 3D printed, which it's not very exciting.
And Scott, since you're
Something's
not
better
here,
than nothing.
since you're not here, why don't you tell us where people can find examples of your work, or where should they look to learn more about what you do?
Okay. Well, you can see some.
Hang on.
Live shows on YouTube if you search for Groucho Fractal. I have a website as well, grouchofractal.org. I'm currently in the process of putting up a new version, but if you want to see a description, you can go to eviltwinbooking.org/live-arts/Groucho, spelled like Groucho Marx, dash fractal. The documentation for the Mandelbot should be up fairly soon. I'm hoping to have it up by the end of November. And if you come see the live show, you can kind of check out what kind of gear there is. It's always constantly changing.
Very cool. DUANN, what's a good website or a resource for people to go to check out these materials, or to see what the new options are, or where to get a sense of the variety of these rapid prototypes?
Yeah, if you go to, I think, a site called 3dprint.com, they have a barrage of information coming out every day of random things that are happening in the industry. And if you want to get access to a 3D printer without buying one, you can go to shapeways.com, which is an online 3D printing service. So there you have a wide range of materials, from nylon to acrylic to stainless steel to sterling silver, brass, bronze, gold, platinum, blah, blah, blah.
And there are a few marketplaces for these items too. What are some of the ones that you like best?
So probably, the biggest one is Shapeways, which is an online marketplace as well. So you can take a product to market and they'll print it on demand and send it to your consumer, and you just get the cash. So it's a way of getting that passive income for a design. So you can buy someone else's design or sell your own. There's also Sculpt.io, iMaterialize. Also have a printing service in a marketplace. So it's an easy way to get access to those materials now.
Where should they be looking for your stuff?
So for electronics, there's not as many resources, but there are a few where you could go and just Google like electronics designs. But right now, you may be able to find some on like the Thingiverse by MakerBot, where people are designing this thing and it needs some electronic component to it. So you may be able to find electronic designs that go hand in hand with a 3D object that's being printed. But right now, electronics doesn't have that huge, like, this is a great repository for designs.
Yeah, there's Circuits.io, or 123D Circuits, is an online design tool for designing your own circuitry. What do you call it? Is it circuitry?
Well, it's more of a schematic.
Yeah. And so the next generation of that will be 3D as well. So you can then design a 3D printed part to have those electronics built into them as well. Yeah. And there's a service involved as well. So you can design it and then they'll manufacture it and ship it to you.
Yeah. And I'm assuming people can see your stuff in action at the Bot Factory website, correct?
Yeah. If you want to see like electronics being made or how our machine works, you can check out botfactory.co to see like it printing or assembling circuits.
Great. If you in the audience over here, if you want to just make a line behind the microphone to ask your questions, yeah.
You can go first, because it's you.
All right. So we've got a couple people lining up for those of you at home.
I was just going to ask if you guys have any really particularly great books or resources to recommend for people that want to teach themselves how to begin designing in software.
The internet. So YouTube is the best way to go. There's loads of different places. If you want to get paid, there's lynda.com, has really complex.
Can you spell that out?
lynda.com has things you can pay for to do proper tutorials through, but YouTube has so much information.
Yeah, I had a question. Is there any like printable, inflatable type like structures where you could actually print the uninflatable portion large enough and then inflate it?
I haven't seen any research on that yet.
There are.
Yeah, you can actually. Sorry.
Go ahead.
You want to go first?
Well, I just know that there are flexible filaments that don't necessarily have all of that, but I think Scott could answer better than I can.
Thank you. So there are actually several different flexible materials that are out there that are used in medicine, especially for creating flexible bladders for pumping blood or for pumping air. If you're looking for just to make an inflatable thing, like an inflatable toy, there's a material called Ninja Flex that people are printing with. A good place to kind of look for these materials is in they're I'm trying to remember the name for this type of motile device, but it's there are these robots that are inside of they're these robots that will move kind of like a caterpillar, and they're just basically these like little servos that are encased in 3D printed silicone like material. So yeah, you can definitely make inflatable stuff. You could print with silicone.
Hey, so I'm curious about what you see as the future of non-software ways of designing. So like right now, if someone's a sculptor and they don't want to get involved in software, they can sculpt something and laser scan it. Maybe there's a future in like haptic equipment or something like that. Can you speak to that a little bit?
Yeah, scanning's a really good gateway to 3D print. If you don't, but it still needs software. Everything's software. It's basically, if you don't have a digital file, you can't make that thing happen. And scanning is a good entry-level way, but often you need to modify, improve, and hack at that to make it work.
Yeah. Some of the scanners are fairly new to market for 3D printed objects, and things like the Google Tango that will go and scan a room is only in its first dev kit shipping now. That's going to be really fascinating as we move into virtual spaces too, and how we can collaborate in virtual spaces that are scanned or digitally designed. And there's a lot of potential for that, but you still have to be fairly literate with the back end of animation or the software tools.
Yeah, it'll come in everything. So right now you can take 40 photographs of an object around it and make a 3D model from that without having any scanning software. Like it's some word, photogrammetry they're using.
Photogrammetry,
yeah. So and then all these. So Apple bought a 3D sensing company. Intel have something. So everyone's looking to 3D space, and it's going to be in every device eventually. And then it may not be necessarily about printing, but recognizing the objects around you, and then how you interact with them will be interesting.
So we have a
There are also
question.
several different. Oh, sorry. Oh, there are also. Should I go, or do you want to go?
Go ahead. Yeah.
Okay, there are also several different pieces of software that are being developed for VR, or virtual reality environments, in which you can use your hands to create sculptures, or you can use controllers. I'm trying to remember the name of the program, but it's there's a paint program that is part of the development kit for the valve. I'm trying to remember the name of the valve. I think is it the Vive? It's the HTC Vive. Yeah, Yeah, you can basically like create these three-dimensional objects like while you're inside of a VR environment. So you don't necessarily need to engage in coding. You can just actually use your hands for sculpture.
Very cool.
So we have a question from the Facebook group. I'm interested in integration of web application services with 3D printers. Can a design be crowdsourced through a community application, then sent to the printer? What sanity checks and safeguards do 3D printers have to make sure a design is actually printable? Are there heuristics to improve a design?
Okay, so you can do whatever you want, but it may not work. So the problem is, so the basic thing is, if it's too thin, it won't print, and that's one of the main problems. Is that in the years that I've seen happen is people just don't. Any design you do in any industry, you need to design for the materials and processes by which it's going to be manufactured. If you don't understand those materials and processes, then you can't design for it well. And 3D printing is not a magic box where you can design poorly and get awesomeness out. Whatever you put in, you get out. So if you do flawed designs, you'll get flawed objects. So it's all about understanding the materials and designing for it.
Well, I can add a little bit to that too. The printer that I made, we put a lot of effort to make sure that the software is really good and easy to use. So we actually try to check all of the users' designs before we print them, and while we don't stop you from printing anything, we will kind of show you a preview so you can look at our preview of what we know we're able to print, and you can see that your design either matches what we say we're going to print or it doesn't match. And if it doesn't match, then you kind of have to go back and, rework your design so that it does. And I think some other like slicing software will show you kind of a preview of what it's going to do, but of course there are printer settings and material properties that you have to worry about that the slicer doesn't necessarily know, so that could also spell trouble.
Yeah, and you need to know design intent to be able to do that. So let's say you're designing an iPhone case and you make it too big. It's not going to fit if your design is flawed. But maybe the designer wants to put some plastic object in between the iPhone case and the iPhone, and so they've designed it oversized for that reason. It's almost impossible to control that, and you just got to let things happen and let people learn from their mistakes, because that's failure is the best way to learn.
So I think we're going to wrap it up, and I'd like each one of you to leave our audience tonight with what's the next big challenge that you hope that everyone in the room, at home, on the internet, and out there in the world is going to be able to approach and solve in this space? What's the big challenge and what's the coming thing?
I would love to see a kind of all-in-one 3D printer where you could kind of make any material you want with any sort of density and just have everything integrated together. So instead of having, my circuit printer with someone else's object printer and then integrating them, you could have, a fabric printer, so you could print a garment that maybe has some hard plasticky parts to it and has some electronic wearable device, just printed and integrated right into that. And of course, just have it connected to the internet so you could access it from anywhere and, print whenever you want.
Yeah, and the other side, so there's three things that make additive manufacturing happen. There's software, hardware, and materials, and they all need to go hand in hand at the same time. So if you have this magic machine which does everything, if you don't have the software which can design for it, then it's just a magic machine which does nothing. And if you don't have the materials developed for that magic machine, then you've got a magic machine and awesome software with no way to make these objects happen. So what I think is important is that we see all three things happen simultaneously so that we can make the magic machine magic.
Scott, let's hear from you.
So one of the things I think we're going to see is a shift in the types of things that we consume. That if we have 3D printers in our communities, in our homes, I think that it's going to be less likely in the like in decades to come, that we're going to have pre-made objects already. we'll wind up having a distribution of materials, like raw materials, of varying qualities. For example, if you're going to 3D print a circuit, it's possible that that you won't actually have the same type of you won't even have the same type of circuit creation anymore. You won't have like surface mount circuits. You'll actually have different materials with different resistance and capacitance being printed onto various types of substrates. It won't actually look like a circuit board any longer, and you'll be able to have everything printed. You won't have as many distinguishable parts. That's what I think is going to be in the future.
I want to thank all of our panelists, as well as Eric Tinker, the Spry Group, and of course Adorama, for being here, for helping us be here tonight, for being here tonight, and of course everyone who's come and who's watching at home. We hope you'll tune in again. Join us at the Pax Solaria Facebook group, and let's give a round of applause to our fantastic panel.
Thank you, guys.